Hi, my name is Vandana, and today I'm going to be talking about functions and some of their properties. In order to understand these, we need to first define what a function is. I like to use the machine model. Think of a function like a machine that takes in an input and gives out an output. Each input corresponds to exactly one output. Another example is a vending machine example. In a vending machine, you can get drinks such as Pepsi, Coke, Sprite, etc. If I press a button for the Pepsi, I know I'm going to get a Pepsi as the output. There can be more than one button that I can press to get a Pepsi. However, there will never be an instance in which I press a button that I'll get a Coke and a Pepsi. This simply does not occur. Each input has exactly one output that it corresponds to. We call the domain the set of all the potential values that they can input as, and the codomain would be all the potential outputs. A function can be written two ways, and these are the two ways of function notation. We can map the domain to the codomain and describe the relationship. Here, the domain and the codomain are both integers, and the relationship is x plus 5. So f of 12 would be 17, f of 10 would be 15, and f of negative 5 would be 0. Another way that we could do it is describe the set of the domain to the set of the codomain. Here we have three different students, and we're mapping them to their ages. So Jake is 18, Shreya and Emma are both 20. Notice how 19 and 21 were not included, or were not mapped onto. And this is something important that we have to know. Every element in the domain has to map to an element in the codomain, but not every element in the codomain gets mapped onto. The set of the elements in the codomain that get mapped onto is called the range. Now, it can be kind of hard to understand whether a relation is a function or not. Graphically though, there is a shortcut that we can use. This is called the vertical line test. When we have a relation, we can draw a vertical line through, and if that line crosses one or more than one point, then we can determine that that function is not a function. Here we have several examples. Look at x cubed. No matter where we draw a vertical line, it will never cross more than once. However, this cannot be said for the rest of the functions. For x equals y squared, we can clearly draw a vertical line here, and this crosses the function twice, meaning that it is not a function. The same thing can be said for a circle. I can draw a line right here, and it crosses more than once, meaning this relationship is not necessarily a function. For y equals the absolute value of x, no matter where we draw the vertical line, it'll only cross once, meaning that this is a valid function. This might be a tricky example. This is a piecewise step function that is a ceiling function. However, no matter where we draw the vertical line, it only crosses once. This means this is a valid function. For y equals 2 to the power of x, the same can be said. And this is a special scenario. Notice how the domain is the set of positive reals, where the codomain is all reals. No matter where I draw the vertical line, it'll only cross once. This is an inverse function, and this might be another tricky example. Even though I draw a vertical line, it won't cross the function more than once. Notice that when I plug in x equals 2, I get n-defined. This is because when I draw the line at x equals 2, it doesn't cross the function at all, meaning that this is not a given function. Now, the two properties that I wanted to teach you guys today are onto and one-to-one. When a function is onto, that means that every single element in the codomain is mapped to by an element in the domain. Or in other words, the range is equal to the codomain. And this is a formal definition. For a function to be one-to-one, that means that no two elements in the codomain share an input. This means that each value in the codomain has exactly one value in the domain that it maps to. And here is the formal definition for that. If a function is both onto and one-to-one, we can say that it is bijective. And like the previous example, it can be kind of hard to determine whether a relation or a function is bijective or not. Luckily, we have another short trick that we can use. This is called the horizontal line test. Similar to the vertical line test, the horizontal line test, if it crosses more than once, or if it doesn't cross at all, we can determine that that function is not a bijective function. Now here are the examples again, and we will see which one of these functions is bijective and which aren't. Let's look at y equals x cubed. At any point, I can draw a horizontal line and it'll only cross through once. This means this is a bijective function. Now, let's look at y equals to the absolute value of x. Now, clearly we see if we draw a horizontal line here, it crosses more than once, meaning that it's not bijective. Looking at this ceiling function right here, we can see that if we draw a line right here, there can be multiple instances that cross the line, which means that it's not bijective. 2.7 gets rounded up to 3, and so does 2.9. Since these two share the same value, it is not one-to-one. Looking at the value of y equals 2 to the power of x, we might be inclined to say that this is a bijective function because it only crosses once. However, this is not the case. If we draw a line down here, this does not cross anything, which means it's not a bijective function. This last one though, we might be inclined to say that it is a bijective function, and we are right, because anytime we draw a horizontal line, it only crosses once, meaning that this is a bijective function. Thank you for listening, and I hope this helps clarify functions and bijective properties.